Unit 1, Linear Models and Functions. And this is all about Activity 2, Problem Solving. Learning to model and solve problems is one of the major goals of this course. The strategy used to solve the word problems is called the general problem-solving process. This activity will help you practice the steps of solving word problems that may be unfamiliar to you and may even contain extraneous information. In this activity, you will work on the following skills connected to the problem-solving process. The first one, identify and organize important information and extract extraneous information. Also, you will state assumptions necessary to solve the problem. You will make reasonable estimates and document your thinking. You will use a linear model to find a precise answer to a problem. You will write a sentence to interpret your answer in context, and you will check your answers, and those are both free of errors and are reasonably correct. Let's start with the warm-up. These are the skills and review problems, and you will always see this at the beginning of every activity. And I expect you to work on these warm-up problems. Okay, pause this and try to solve this problem. Problem number 1. Find the equation of the line that passes through the points -14, 9, and 21, -1. So let's recall. Since we are talking about the equation of a line, you learned this in activity 1. We have y equals mx plus b. And m is the slope and b is the y-intercept. B is the slope, which is rise over run, change in y over the change in x. So let's have here, this is your x, this is your y, this is your x, this is your y2, x2. So change in y, so that is -1 minus 9 over the change in x, 21 minus -14. -1 minus 9 is equal to -10. 21 minus -14 is 35. So your slope is -10 over 35, or they are both divisible by 5. So that is -2 over 7. Next, how do we find the slope? You can use either of these 2 points. You have x and y. Plug in that to y equals mx plus b and your slope, and you will be able to solve for b. So let's use the first one. So y is 9. Equals, the slope is -2 over 7, x plus, x is -14 plus b. 14 divided by 7 is 2. So this is 9 equals -2 times -2 is 4 plus b, and then subtract 4. 9 minus 4 is 5. So your b is equal to 5. And we'll use that to write our equation of the line. And we will have y equals mx plus b. M is -2, 7, x plus 5. So this is the equation of the line. Next, number 2, the water pressure measured in pounds per square inch on a diver increases as she goes further underwater. For example, at a depth of 32 feet underwater, the typical water pressure is about 29.4 pounds per square inch. Define variables for this problem situation. So you mentioned here the depth of 32 feet underwater. So that is 1. And that measures in feet, and the other one is measured in pounds, the water pressure measured in pounds per square inch. Okay. Number 3, let's do the same thing. In 2001, approximately 125 million personal computers were sold worldwide. In 2007, this number had risen to 264 million. Define variables for this problem situation. We have in 2001, it was 125. In 2007, it increased to 264 million computers. So we can say that our variables are the year started in 2001 and computers sold worldwide, that is in millions. Next, which of the following tables show a linear pattern, and document your reasoning. You can tell if a table is linear by looking at how x and y change. If as x increases by 1, y increases by a constant rate, then a table is linear. You can find the constant rate by finding the first difference. So let's check that. Letter A. The first difference between these two, 20 minus 10 is 10, 5 minus 0 is 5. How about the next two? You have this 30 minus 20, you have the same, 10. But how about this? 15 minus 5 is 10. It's not the same. So meaning this is not linear. Letter B, let's do the same thing. 7 minus 9 is negative 2. 6 minus 2 is 4. 5 minus 7 is negative 2. 10 minus 6 is 4. It's the same. The change is the same. Change in x and change in y. It's like you will be able to solve for the slope, which is negative 2 over 4, which is equal to negative 1/2. So yes, this is linear. Letter C. 16 minus 4 is 12. 4 minus 6 is 2. 40 minus 36 is 24. 8 minus 4 is 4. If we solve the slope here, 12 over 2 is 6. The second, 24 over 4 is also 6. So they have the same slope, and yes, this is linear. Letter D. 1 minus 11 is negative 10. 0 minus negative 4 is 4. Negative 11 minus 1 is negative 12. 4 minus 0 is 4. They're not the same for y, so this is not linear. Okay, let's start our class discussion for this activity. We have one problem here. A biologist is interested in knowing how the concentration of a contaminant in a lake is changing after a chemical spill. She takes several measurements of the concentration of contaminant after the chemical spill. After 4 hours, she measures 450 milligrams of contaminant per milliliter. After 12 hours, the concentration has decreased to 60 milligrams per milliliter. The biologist assumes a linear model will be appropriate for this problem. Create an equation and then use it to determine when the concentration will drop to 0. Letter A, identify the questions or tasks in the word problems or word problem and paraphrase. So here we want to create an equation and then we want to determine when the concentration will drop to 0. Identify the important information and organize the information in a table. What do we have here? After 4 hours, he measures 450 milligrams of contaminant per milliliter. So let's see, 4 hours. Yeah, the 450. And then also we have after 12 hours we have the concentration has decreased to 60 milligram per milliliter. Letter C, extend the table from part B using a linear pattern additive, and then use this extended table to estimate the answer to the question from part A. So here we're going to estimate our answer to the question from part A. Remember, we want to determine when the concentration will drop to 0. So what do we have so far? We know that we have 4 hours. After 4 hours, it was 450. And after 12 hours, we had 60. And 60. So here, change in x, we have from 4 to 12 is 8. How about we do that? So 12 plus 8 is 20 here. Then from 450 to 60, that is like the change is 390. How about if we do that here? If we subtract 390 here, the change in y, this will be negative 330. But we want when the concentration will drop to 0. So definitely it's between 12 and 20. So how about if we try in between of 4 and 8? Let's see. Oops. 12. 8. Sorry. When it is 8, so 450 minus 60 is like the average of these two is at 255. And now you will see that there is a decrease of like 195 here. 195. If I subtract 195 here, what is 60 minus 195 is negative 135. That is every 4, so this is at 16. But still we want at 0. So again, it will be between 12 and 16. So meaning we can approximate that it is like 13 or 14. And letter D, clearly define the variables that will be used to answer the questions in part A. What do we have? The time. Definitely we use the time. We started at 4 hours and we have 12 hours, and we want when it will drop to 0, and also the measurement of the concentration of contaminant after the chemical spill, or concentration of contaminant. That is in milligram per milliliter. So the time here is the number of hours. Let's change that. After the spill. Letter E. Find an algebraic model or equation for the information in your table from part B. Okay, so to find the equation, we have this given. After 4 hours it was 450, and after 12 hours it was 60. So to solve, first we want mx plus b, so we want to get the slope, the change in y over the change in x. 60 minus 450 over 12 minus 4. Negative 390 over 8, and that is equal to negative 48.75. So that is our slope. And then for the y-intercept b, let's use the first. Y is 450 is equal to the slope negative 48.75x plus b. Oops. B is, x is 4 plus b, and if you multiply negative 48.75 and 4, that is 195 plus b, and then add 195 to 450, that is 645. So now we have the slope and the y-intercept. So the equation is negative 48.75 plus 645. Next one, letter F. Use your model to find the precise answer to the equation from part A. Write your answer in a complete sentence using the correct numbers and units. So from the last slide, we got an equation, y equals negative 48.75 75 plus 6.645. So to answer A, when the concentration will drop to 0, so we want to solve, when will it drop to 0? We want to solve when y is 0. So what we do here, we subtract 645 both sides. And then we divide both sides by negative 48.75. And you'll get x approximately equal to 13.23. So that means the concentration of contaminant in the lake will drop to 0 after 13.23 hours. We estimated earlier it was approximately 14 hours, and we got the exact answer as 13.23 hours. Is your precise answer reasonable? Definitely yes, it should be less than 16, because it was 16, it was negative, and we wanted it to be between 12 and 16. Letter H, interpret the meaning of the y-intercept in your equation in the context of this scenario. So y-intercept, that is when crosses the y-axis, that is when x is 0. So meaning at the beginning, the measurement was 465. This should be 465 milligram of contaminant per milliliter, because that is the y-intercept. And letter I, interpret the meaning of the slope in your equation in the context of this scenario. And our slope is negative 48.75. So meaning there is a decrease of 48.75 milligram per milliliter per hour. And the last one, in the problem description, the biologist assumed that a linear equation would be appropriate to solve this problem. What does this assumption mean in the context of this problem scenario? With this type of problem, linear equation word problems usually involve some sort of rate of change or steady increase or decrease based on a single variable. With this, it was given from the problem. After 4 hours, she measures 450 milligrams of contaminant per milliliter, and after 12 hours, the concentration has decreased. So the biologist wanted to measure the concentration of contaminant after the chemical spill, and she saw that there was a decrease after how many hours. So that's why she assumed that linear equation would be appropriate to solve this problem. And the very last slide here, sorry. This was from the packet. This is the problem solving process. Use this process for more open-ended problems. You can use this all the time. Number one, understand the problem. So you should always paraphrase the situation or task, identify the important and extraneous information, state any assumptions, and make estimates when possible. Also, devise a plan. So define your variables, independent and dependent variables, or your x and y. Draw diagrams or create charts or tables. That will be a lot easier. Make a statement or plan about how you will answer the question using the identified important information. Next, implement the plan. Show a careful step-by-step solution process. Edit or update your plan from step 2 whenever it is necessary. And the last one, answer the questions and review your work. You always check your work and check the solutions if it's reasonable. State the problem solution in words in context and then extend the problem. Okay, that's it. This is activity 2, problem solving. Thank you.